Hello everyone and welcome to the Servo channel. Today we are diving into the world of CAN communication and if you CAN communication, I will give a brief about it. CAN is majorly using in automotive while uh, in medical also they are using CAN communication because of this robustness and low cost and many are there. I will explain you further slides. First we see like how CAN is innovated like in software and hardware and everything is like in real life we are innovating something and better than the previous one. Here also CAN is similar actually. So we have already we have many protocols, communication protocols available before CAN invented like UART communication, SPI communication, and two-wire or I2C communication and Ethernet. So we can see very briefly all about all the communications. So it is like CAN is built by using all these good features from UART, SPI, I2C, and Ethernet, and the developed the CAN protocol. So here we can see UART communication. So here this is the like very basic communication, and it is working based on the baud rate. So here you're transmitting message with baud rate of, for example, 9600 megabits per second. Same thing in receiver side also it should match like same baud rate. We should set actually 9600. Then only your all the message will receive properly, or we can send the message. Yeah. So this is very basic communication. But here you can see the drop and disadvantages also by using this UART. So there were no error handling actually in this UART communication. Very simple. It is very simple and there is no complicated. But these things we can't use it in any other application like. Mm, For example, if you're designing some like healthcare devices, so these things we can't use actually. So there is no error handling. So it is a critical device medical. Or if you take Adasa, so we are running the vehicle and so this is not useful actually. But here we can see, but it is a very basic communication. So here you don't require any wires actually. You can require only one wire is required actually for sending, and for receiving you need one more wire required. It is a full duplex actually. So let's jump into another protocol. Here drawback is there means what drawback I can see is like one is mainly it is error handling and noise is more in this, and there is no point-to-point communication. Multi-point communication. So there is a only transmitter and one receiver. So here we go next. Next is the SPI communication. So here we having a master and slave concept. So you can connect the number more than one slaves. You can connect many slaves actually to one master. Here the advantage actually compared to UART. And here also you can connect some of the only some number of slaves actually can't connect more slaves here it is more complicated your design will be because we want to chip select. So here you can see only one line of chip select and other than this SPA is good actually compared to UART, but here This SPI, you can't communicate with the longer distance actually, but speed is more here compared to what you can see this SPI in most of communications. It will be mostly used in our boards only actually, not outside the board actually. If you take PCB, you can access your memory and that kind of interface you can do actually SPI. So it is also serial peripheral communication. This is also full duplex. Actually, you can transmit and receive at any time. So this is a synchronous communication. And here drawback is that you can't communicate longer actually. And the slave also you can't connect more than very limited slaves you can connect, and if you connect more slaves, it's gonna be complex. And next, coming to I2C communication, two-way communication, this is very, what you can say, this is very simple communication compared to your UART and SPI. So SPI having a four pins, but here we having only two pins. One is S clock and one is S data. So here we having a many features actually compared to your UART and SPI. So here you can connect number of these layers actually, complex is less actually, and this also you can need to see. This is you can communicate actually very long distance actually compared to SPI and SPI. So here we can see some of the advantage, but the disadvantages here is mm, here speed is less actually compared to SPI. Other than that, this design complex is more because we're having a two wires only, so it is very complex, actually complex compared to SPI. But here we having an advantage, like we'll get a AC actually once you transmitting from master to slave. So slave will send the acknowledgement to the master. So we having a some kind of error arrangement. So it is very good features actually if you compare to SPI and you some of the application like critical application we need this kind of connection protocol, so we need some ASIC and all, so that things it is available I to see, but it is very complex and you can't connect many master, and so it is just master slave communications. Next we'll go to this Ethernet communication. So Ethernet is very complex communication, right? So we having so many wires actually, and this is what CAN is similar to Ethernet, but the Ethernet are having some disadvantages also, like compared to CAN. So here there is no message operation things, and prioritize message prioritization is not there compared to CAN. And it is not suitable for some of the application, and it is very complex actually compared to the SPI UART and I2C. Ethernet is very complex. You need some complex device drivers to enable this Ethernet in any of your microcontroller. So other than that, it is having everything actually. Only thing is complex and very. We need a separate chips and all. So here we see now every communication protocols in beginning your communication and extra SPI and I2C and Ethernet. So now we having an idea actually my medical and research application not require that complex uh, things like Ethernet. So what I will do is I will take some of the features of these protocols, some of the good things. In your we having a good thing is pod, right? And we having two ways for one sending message, one for receiving one message. We having two cables. We'll use that features into our CAN, and it can also will use portrait. And if you coming to a spy and I2C, we having a master slave concept. We take that master and slave concept, and spy. I don't remember actually. So at the Ethernet, we can take running futures actually. So to buy together, so we can this CAN communication is formed actually. So here you can see we having a canvas and you can connect a number of uh, issues actually. Here there is no master and slave concept. Everything is like act as a master sometimes. Everything is act as a slave. One is considered as a master and it can do anything actually. So here error handling feature also there in that and message priority is also there. Like some of the issues should be give first priority actually. So some of the critical like if you take Tasar, so you need we having an airbag and the emergency braking system and all. If you from those sensor if we coming any message means we have to give those priority first. First we have to complete that task. So remaining to this lower low priority task. This is all about CAN communication.